Hello, this is geometry lesson 5.1. In this I will continue with centers on triangle. The next center is circumcenter. This is a point where perpendicular bisectors meet. Now very important thing to observe is that perpendicular bisectors are not drawn from the vertices. How they are made? Let me show you. This BC is a side. These perpendicular bisectors are drawn by compass. This you can make. This is a perpendicular as well as this is a bisector. They are not drawn from vertices. Same way from this triangle. This is a perpendicular as well as bisector. Same way from this side. This is a perpendicular as well as bisector. Let's say this point is D, this point is E, this point is F. So this point O is called as circumcenter. This point O is called as circumcenter, where perpendicular bisector meet. Now, if we join this point, if we join like this, let's say this AO, we join BO as well as CO. Now what will be the property of this? First, I can say that AO will be equals to BO will be equals to CO, and this is called as capital R, that is circumradius. This is circumradius. It means that if we take O as a center, and we can draw the circle by taking O as a center and radius as BO, OC and AO. This circle, you can draw, this circle is called as circumcircle. This circle is called as circumcircle. We can draw the circumcircle over every triangle. This can be drawn over every triangle because circumradius will exist for each and every triangle, so there will be a circumcircle also. Now the point is that how you can say that these radius are equal, that is BO, AO and CO are equal. We can easily prove that. Can I say that this triangle 1, this is triangle 2, I am taking. Triangle 1 is congruent to triangle 2. Triangle 1 is congruent to triangle 2. This is a sign of congruency. How they are congruent? You can see that OD is same. OD is same. 90-degree angle is same, as well as BD is equals to CD. So they are congruent by SAS, side angle side. One side OD is common, one angle is common, and one side BD. So angle is in between the sides. So SAS congruency, these two triangles are congruent. When the triangles are congruent, all corresponding sides are equal. So we can say that BO will be equals to CO. The same way we can prove that BO will also be equals to AO. So we can say that AO will be equals to BO will be equals to CO, that is equals to circumradius. It means that if you can take O as a center and radius as AO, BO or CO, you can make a circle, and that circle will be called as circumcircle. And circumcenter will lie inside the triangle in an acute angle triangle. Where the circumcenter will lie in a right angle triangle. Now you can see that. Let me draw this diagram. This is a perpendicular as well as bisector. Same is this. This is perpendicular as well as bisector, and same is this. This is perpendicular as well as bisector. Now you can see that these three perpendicular bisector, this point O, this is called as circumcenter. So very important point in a right angle triangle O, that is circumcenter CC. Circumcenter lies on the midpoint of hypotenuse. On the midpoint of hypotenuse. Very important property. In a right angle triangle, the circumcenter lies on the midpoint of hypotenuse. It means that you can draw the circle by taking O as center, and radius will be OE, OD and OF. They will be considered as radius, and you can draw this circle. So circle will be this circumcircle. Circum radius R would be OE, OD and OF. Each of them will be equal. OE may or may not be perpendicular, but it will be equals to OD and OF, because O is the center, and you can say that OE, OD and OF all are radius. This is capital R, this is capital R, this is capital R. They are called as circumradius. Now where will the orthocenter lie? In an obtuse angle triangle. In an obtuse angle triangle, the circumcenter will lie outside the triangle. This is perpendicular bisector I am making. This side equals to this side. This is perpendicular bisector I am making like this. This is perpendicular, this is bisector, and same is this. This is perpendicular bisector. So they are meeting outside the triangle. So this point is O. So very important, in an obtuse angle triangle, the circumcenter lies outside the triangle. In a right angle triangle, the circumcenter lies on the midpoint of hypotenuse. And in an acute angle triangle, this is acute angle triangle. This is right, and that was obtuse. In a acute angle triangle, the circumcenter lies inside the triangle. And there is always a circumcircle and there is always a circumradius. I have proved that how to draw the circumradius and how they are equal. They will be equal by property of congruency. Next is Incentre. This is a point where angle bisector from vertices to opposite sides meet. Angle bisector. Now, angle bisector means the line which this angle which will bisect the angle. This is alpha and alpha. This angle bisector AD. Same way we can make angle bisector B. This is beta angle, this is beta angle, this is BE. Same way we can make the angle bisector as CF. This angle is theta, this angle is also theta. So these three angle bisector, let's say, meet at the point O. This point O will be called as Incentre. This point O is called as Incentre. Now what is the property of Incentre? That we can take this as a center, and within radius, some radius, we can draw the circle inside the triangle. So will can I say that OE, OF, OD are in radius? We can draw the circle. If there is a center, there must be a circle. Are they in radius? No, they are not in radius. For in radius, we have to make them perpendicular. OD is not perpendicular. Let's say this OD dash is perpendicular, I have drawn. Same way OE dash, this is perpendicular, and OF dash, this is I am making perpendicular, OF dash. Now once I am making three perpendiculars, now I can say that I can take the triangle. I am taking a triangle. Can I say the triangle BOF dash? Triangle BOF dash, you can clearly see that BOF dash is congruent to triangle BOD dash. Why these two triangles are congruent? You can see that they are congruent by ASA, angle side angle. You can see that beta angle is there in both the triangles. 90-degree angle is there in both the triangles. You can see that this angle will be also same. This is let's say alpha and alpha. So beta and beta are same. No need to take 90-90. Alpha and alpha are same. And one common side, BO is equals to BO. The common side. So common side is there. BO is equals to BO. Beta, beta, alpha, alpha, 90-90. Because when two angles are same, beta and 90, third angle will also be same. So these two triangles are congruent by ASA. When the triangles are congruent, you can say that the corresponding sides are equal. So OF dash will be equals to OD dash. Same way we can prove that OF dash will be equals to OE dash. Now I can prove that OF dash is equals to OE dash is equals to O dash OD dash. These three lengths are equal from the center O, and this is called as in radius, small r, this is called as in radius. And we can draw the circle and that will passes through this circle is called as in circle, and radius would be in radius, that is small r, and that will be called as in radius. Now important point here to observe is that in radius is there and in circle will always be there in every triangle. Now what I want to show is that where will be the orthos in center in a right angle triangle. In a right angle triangle, the orthocenter will also lie inside the triangle. This angle bisector 1, this angle bisector 2, this is also angle bisector 3. This point O will be the orthocenter, and there will be a circle, and this circle is called as in circle. Same way in obtuse angle triangle also, the in radius in center will be inside the triangle, because this is angle bisector 1, this is angle bisector 2, this is angle bisector 3. So they will also meet inside the triangle. So very important that in center always lies inside the triangle, whether it's a acute angle triangle, whether it's a right angle triangle, or it's a obtuse angle triangle. Important property here is that in center will make in circle. That center you can draw the circle, and that circle will touch all the three sides of the triangle, and there will be in radius also, and that in radius is called as small r. So that was all about centers of triangle. That was the basic that I have covered in 2 lessons. Thank you. In the next lesson I will continue with more on geometry. Thank you.